everybody. Hope you're having a lovely day. Today's lesson, we're going to be talking about properties of squares and rectangles. If you'd get out your booklet, that's 4.15, and it's 3 out of 3. We're going to be learning again about properties of squares and rectangles. And just to review something we talked about last week, we learned that a square has all equal what? Sides. That's correct. So all these sides are equal. So if this was 2 centimeters, all the sides would be 2 centimeters. The lengths would be 2 centimeters. And the angles in these triangles are all 90 degrees, which you know is a right angle. Correct. And then with a rectangle, we know that the sides of the rectangles are this length and this length are equal. And the lengths up here and here are also equal. And we also know that the angles are all right angles, which again is equal to 90 degrees. Okay, wonderful. In the first example, the diagram below shows a folded rectangular piece of paper, ABCD. BC equals 5 centimeters. FC equals 5 centimeters. FD equals 2 centimeters. Find the length of AB and AD. So if we were to put the angles here, let me just back this up a little. And here we go. We know that, let me write these angles down just to make it easier. A, go down here to B, C, and D. Very good. So the problem starts out like this here. And this is what we do know. What we know so far is that the line from D to F equals 2 centimeters. We also know that F to C equals 5 centimeters. And we also know from B to C is equal to 5 centimeters. So it's telling you to imagine the paper is unfolded, right? So you have angle D here is up here now, and imagine that, right? And we also know that if this is 5 centimeters in our rectangle, that's right, that A to D is also 5 centimeters length, the length. Okay, so, and they're asking us to put an imaginary line in here from where D once was here. I can just show you. Actually, this might be a little bit more helpful. If I go like this here. Okay. And you can probably see that here. A little bit darker for you. So A to D here. Your imaginary 2 centimeters. It shows you this triangle here too. They're not to scale, but I'm just trying to get the concept across for you. So the imaginary dotted line, you'll see on your paper, they show it as a dotted line. So if this is 2 centimeters, we lift this up. The 2 centimeters, look at that, are now here. This here, this here, here, 2 centimeters. Right? And this is 5 centimeters. So the first question we have here, the information that we have so far, we know D to F is 2 centimeters and F to C is 5 centimeters. So here they're asking, the first question is AB, well, we know this, AB equals DC, and DF, we have DF plus FC is 2 centimeters plus 5 centimeters equals 7 centimeters. So we know then this is equal to 7 centimeters. So then we know, because these are equal, AB is equal to 7 centimeters. That's the first answer. And then we also know AD equals BC, which we've already gone over. So those are 5 centimeters. So those are the answers to your questions on page 1. And now page 2, if we move over to page 2, the question is, the diagram below, if you just read it to yourself or with me, we can read it together. The diagram below shows a folded square paper, EFGH. Find the angle X. So this is a square now. So here's our square, and it's folded over here like this. This is how we have it started, right? So if we label our angles here, we have this is E, F, G, and H. And they have Q here. And then we have our degrees here. This is 20 degrees. Here's our angle X. So they're asking you to imagine that you unfolded the paper. And then you see here, the same as our other problem, we know that this is 90 degrees. We know that this 20 degrees is the same degrees as it is here, 20 degrees here. Our angle H is really here, right? So, and then we know here is 20 degrees because it's just an identical triangle right there. See how that matches? So we know that these two are 20 degrees. So after unfolding the square paper in figure 1, triangle HEQ, HEQ, and the dotted line of figure 2 here are identical, which we've just discussed. Since it is a square paper, we know that angle FEH, so angle, we have FEH equals 90 degrees, right? So we could just plug in the answer with all the information we have here to solve the problem. Angle X, which we're trying to solve for here, angle X equals 90 degrees. And we're going to subtract the 20 minus the other 20 degrees. And that equals, that's right, 50 degrees. So you can write it out, make it look a little bit neater if you wanted to. You'd say angle X equals 50 degrees. Here. Okay, so we're going to move on to now the guided practice on page 3. And we can review the first one. The figures are not drawn to scale. The figures are folded squares and rectangles. Find the length of the unknown sides and fill in the blanks. So here we are with our first one here. And the information they give us, we already know. We're looking for angle A to B here. And this is, we know that this is 5 centimeters from B to C, right? And we know that this here is 5 centimeters from this area here. And then they also give you this 2 centimeters on the fold here. So the question is, what is AB? Okay, so we know that this is 2 centimeters here, and if we unfold this here, this is the same thing. This also is 2 centimeters. So to find out, and this D angle's here, to find out what A to B is, you just simply add 2 centimeters plus 5 centimeters. So we say AB equals 2 centimeters plus 5 centimeters equals 7 centimeters. So AB equals 7 centimeters. So you're going to go ahead and work on you can go ahead and do part B, just while I'm clearing up here.